Hello and welcome everyone. I hope all of you are doing well. I'm Anisha. So today we are going to start a new chapter, that is globe, latitudes and longitudes. This is of geography, okay, class 6 geography. So see, this is also a very interesting chapter. From here we are going to learn about the imaginary lines of the earth, about the poles, about the axis, about the equator. I hope you have heard about it, isn't it, before also. So we are going to learn about, especially about latitudes and longitudes. Okay, we are going to understand these two terms. These are very important, and it is the basic term. If you have started learning geography, then you should know what are latitudes and what are longitudes. Okay, so you have to understand the concept behind this. It is very interesting as well. Okay, so see, in the previous video, previous chapter, we have read about our planet Earth, about the solar system, isn't it, that earth is not sphere and it is of a geode shape. It is slightly flattened at the north and the south poles bulge in the middle. See here in the picture also you can see this is a globe, okay, and this will be our reference. Okay, it is a replica, okay, it is a replica or a miniature form of earth through which we can understand earth very properly, like we can understand the maps, world maps, isn't it? Especially when we want to see world maps, it is very easier and convenient for us, okay, when we are seeing it through globes. So here, see, this is the north pole we are going to study in detail, okay, and this is the south pole, okay. So it is flattened over here, okay, it is little flattened over here in this area, all right. And when you look at your globe carefully, you will find that it is a true model, miniature form of the earth. Okay, it is as it is. Okay, it is a miniature, or it is a replica also of the earth, through which it becomes very easier for us to understand our earth. So here, then you will be seeing globes. These globes will be of many types, okay, shapes and size are different, because you might be seeing a very big globes also, isn't it, in some museums or all you will be seeing. And in your classrooms, in your schools, you'll be seeing a small globe which is as shown here in this picture, isn't it, or some pocket globes are also there. And interestingly, some globe like balloons are also there, okay, where these prints, okay, globe prints are printed in that balloon. You'll inflate it, and after you will be seeing it, and after you don't need, you can carry it, you can inflate it, and it is very handy and you can carry it out very easily. So here we can find different size and shape of sizes of not shape, actually size of, okay, size and types of globes. Some are big, some are small, some are like balloons, okay, some are in the form of balloon, and it can be easily folded after use, and you can keep it in your pocket also, isn't it? So the globe is not fixed, it can be rotated. These are not fixed, okay. If when you hold a real globe, if you have a real globe, you can hold it and you can see it is not fixed, it will always rotate, isn't it? It will always revolve and rotate, and it can rotate. It can be rotated the same way as a top spin or a potter's wheel is rotated. See, when you are giving a hand in that globe, when you are giving a spin in the globe, you will find that it is spinning just like what? Just like a top spin or a potter's wheel. And on the globe, countries, continents and oceans are shown in their correct size. So here in the globe, what will you observe? You will see that the countries, the oceans, okay, all of them are given in a very perfect size, very correct size. See here the blue parts, these blue parts, this indicates water, isn't it? And these green parts indicates these are country. So here, see, and we are going to learn about these latitude and longitude. Especially these are, see, what are important, why are we going to learn these latitudes and longitudes? You have to know that as well, okay, because these latitudes and longitudes, our season and our time all depends on these latitudes and longitudinal lines. Latitude will depend on our seasons, okay, about the heat of the sun, and the longitude will tell us about the time, okay. So let us start. It is difficult to describe the location of a point on sphere like the earth. See, as earth is not a perfect circle shape, isn't it? It is sphere and slightly again tilted in the on its pole, on both its northern pole and southern pole, okay. So now the question arises as how to locate a place on it. And see, these lines which you are talking about, okay, which we will talk about, this axis, equator, okay, we will learn about this. These are all imaginary lines, okay. You should always keep that in mind. In practical, in reality, there are no such line present over the earth. Okay, there are no such lines or grid present over the earth. We need certain points of reference and lines to find out the locations of place. See, we need certain points or lines, isn't it, so that we can find out the exact location of a place. How? So you can see in your phone also, now when you open the map, if you want to search some of the place, when you go into Google and you go in the Google map and you search it, you will be getting the exact location with pin, isn't it? A pin location you will be getting. So all that are possible only because of latitudes and longitudinal lines. Okay, so these points are needed as a reference, okay, as a reference to find out the locations of places. So you will see you will notice a needle is fixed through the globe in a tilted manner. See, in the reality such a needle is not there. Okay, here you can see, okay, a needle is been fixed over here, okay, here in this point, here and here, so like this, okay, in tilted form. This is not straight, this is in tilted form. Why? Because earth is not a perfect circular shape, it is a sphere shape, it is a geode, isn't it? It is a geode shape with the flattened with its pole flattened. All right, so what happens is that so this needle, okay, this needle is also a reference. Okay, it is a tilted, it is not straight, okay, which is called its axis. So what is this needle is been named? It is axis. Okay, this is not present in reality. Okay, in the practically it is not present. Just for a reference points, we have imagined that here over here there is a needle, okay, both from starting from this north pole to south pole, and this line, this needle, it is known as axis. Okay, so 2 points on the globe through which the needle passes are 2 poles, north pole and south pole. So these 2 points, okay, here over here 2 points are there. This is the north pole and this is the south pole. Okay, first point is over here, second point is over here. All right, okay, let me do more precisely. Okay, see, let us do again properly. See, these 2 points, okay, here these point, this will be the northern point and this will be the southern. Why this is not? Because see, when you see the direction, this is always upward, it's always northern direction, and downward is always southern direction, isn't it? So this is the north direction, and so that is why this has been referred as a north pole. Okay, and this is the downward direction, so this has been referred as a south pole. So this globe, okay, this globe can be moved around this needle from west to east. See, again, this is the west and this is east, isn't it? And when you move a globe, or see, will be when you notice it, okay, when you move a globe, you will always see the globe moves from western to eastern side, okay, from there to here. That means our earth is rotating from western to eastern side. It is rotating as well, isn't it? It is revolving around the sun and as well as rotating on its axis as well. So here it is rotating from west to east, all right, from west direction to east direction, just as the earth moves. See, okay, and there is a measure, but you should remember that there is a major difference. The real earth has no such needle. As I have told you, the real earth in practical, there is no such needles. Okay, it moves around its axis, which is an imaginary line. Okay, this is all imaginary line. It has been made for our convenience, so that we can use it as a reference to locate a place, especially to locate a place as well as to locate times and season as well. Okay, so just like that. Okay, another imaginary line is also there. Okay, another imaginary line is there, that is known as equator. Okay, that imaginary line, another line that is known as equator. Okay, the northern half of the earth is known as the northern hemisphere and the southern half is known as the southern hemisphere. See, let us try to understand through this picture given over here. Okay, so, and both these are being divided into equal halves. All right, see here, this is the equator. Okay, suppose this is the earth, let us just draw. Okay, so there is a line over here. Okay, there is a line over here. This is also an imaginary line. Okay, so this is the equator. Okay, this line, and this is divided exactly half. Okay, the upper portion will be known as the northern hemisphere, as it is north, and the downward portion is known as the southern hemisphere. I hope it is clear. The upper portion is northern hemisphere and the southern half is known as a southern hemisphere, and they both are equal halves. Okay, these are equal. This area and this area is equally divided. Okay, it is equal. See here, you can see this equator, it is here. Okay, over here. This has been shown from the upward direction. Okay, this picture, so you can understand from here. So therefore this equator is an imaginary circular line and is a very important reference point to locate places on the earth. See, it is circular line. See, you don't forget that our earth is round, isn't it? So here I am showing only you the front part. So same line will be going again in the backward also, okay, in the back side also. So this is a circular line. Okay, just like here, see, it start from here and it will go this side also. Okay, this side also, and so it is a circular line. All right, it is equal. It have equally divided the upper portion and lower portion as southern hemisphere and northern hemisphere. Northern hemisphere, yes, northern hemisphere and southern hemisphere. Okay, and this is also been divided so that this is also important, so that it will be easier for us to locate places on earth. Okay, and all parallel circles from the equator up to the poles are parallels of latitude. See, from the name itself, latitude, landing. Okay, these are on the landing position. Okay, sleeping position, landing position, latitude. So here you will find such lines. Okay, this is our imaginary. Okay, you will find such lines over here in both the southern hemisphere as well as in the northern hemisphere. Okay, these are all parallel, equally divided. Okay, these lines are again equally divided. These are all parallels, so that is why they are called parallels of latitudes. Okay, and latitudes are measured in degrees. Okay, these latitudes are being measured in degrees. Okay, and the equator represents the 0 degree. So here this equator, this line, okay, this circular line over here, so these are also circular. Okay, this is only, you can see only the front side. When if it is a 3D image, in a 3D image you can see that this line will be in the back side also. Okay, back side also same line will be there. So these all lines which are in latitude, okay, landing position, they are known as parallels of latitudes. And these lines, latitude, through latitudes, what we came to know location of the place as well as our season also. Okay, about that we will learn in our zones. Okay, season zones. So I hope until here it is clear. And this equator, this line, okay, this in the middle, which you have divided the earth into two parts, this is 0 degree. Okay, this is 0 degree, and from here till here, okay, from northern, this is a pole, isn't it? From north pole to equator it is 90 degree. All right, and from equator to south pole again it is 90 degree. So total it is 180, isn't it? 90, 90, 180, on in the back side also 90, 90, 180. So total how much it will come? 360 degree, isn't it? 360. So I hope you have understood this concept. See, first half here 90 from north pole to equator, and again from equator to south pole it is 90, 90, 90, it will make 180. So 180 in the front, 180 in the back side. So it becomes 360. Okay. So okay, so this 0, okay, this equator is 0, and from here again you will start 1, 2, 3, like that it will come. Okay, so and every line, every latitude, say there are some gaps here, isn't it? So every line will be of 23.5 degree. Okay, all the latitude lines it measured as it is 23.5, above 23.5 it will be Tropic of Cancer. Okay, about it we'll learn. So first here try to understand this concept what I have just told you. Okay, this is what it has been, they have written here. Okay, so since the distance from the equator to either of the pole is 1/4, see 1/4 out, see 360, if you take out 1/4 of 360, how much it will come? It will be 90 degree. Okay, 1/4 of a circle round on the earth, because the circle dimension is 360 degree, isn't it? So from there we have taken, and it will measure 1/4 of 360, that is 90 degree. I hope this concept is clear. Thus 90 degree north latitude marks the north pole and 90 degree south latitudes marks the south pole. So here these from equator to here southern side it will mark as 90 degree south latitudes, and from northern degree it will mark as north pole 90 degree. I hope it is clear. Okay, so okay, let me draw again here. See, this line is 0, from here till here it is 90 degree, and as this is upward it is north. Okay, north, and here this is south, and from here till here it is 90 degree again, and 90 plus 90 180. So same thing on the back side also. So altogether it will come 180 plus 180, it will be 360. I hope this is clear. Okay, this was about the degrees of latitudes. Okay, so as such all parallel nodes of the equator are called north latitudes. Similarly, all parallel south of the equator are called south latitudes. So this line, okay, this line you will see, this line, this which lies in the northern part, it will be known as a north latitudes, and which lies in the southern part, it will be known as south latitudes. Okay, I hope it is clear. Okay, so let us see one more thing. Okay, see, about here we are going to learn about this topic of Capricorn, topic of Cancer. I hope you have heard about it also, isn't it? And in India also you will find this imaginary line, topic of Capricorn. It is India lies in this, which line? Here in this tropic of Capricorn. Okay. Okay, the value of each latitude is, so okay, now let us take out the value of each latitude. Now we came to know that 90 degree northward, 90 degree south pole, isn't it? Total it is 180 front and 180 back, it will be 360. So now let us try to calculate how much it will be 1 degree. Okay, how much time? The value of each latitude is therefore followed by either the word north or south. So here either if it lies in the northern part, it will be north, if it lies in the southern part, it will be south. So generally these are indicated by N and S. Okay, these northern latitudes will indicate by N, and southern latitude it will be indicated by S. For example, both Chandrapur in Maharashtra, okay, here one example is given, Chandrapur in Maharashtra, India, and Belo Horizonte in Brazil, South America, okay, are located on parallels of 20 degree latitudes. But the former is India, it is 20 degree north of the equator, and the latter is 20 degrees south of it. We therefore say that Chandrapur is situated at 20 degree north latitude, and Belo Horizonte is situated at 20 degree south latitude. See, both of them are on the same degree of latitude. For example, here let us again see. See, this is the earth, suppose this is the earth, this is the equator, here this is the latitude. So somewhere here, okay, from here you will count 1 2 3 4 5 6 until here it will be 90. Okay, until here again 90. From here you will be counting 1 2 3 4 5 till 90. Okay, so here somewhat here in India. Okay, so it is located in 20 degree in 20 degree of northern India. Okay, because this is north and this is south. So both of them are located in the same degree, okay, in the same degree, but one is in the northern side and another is in the southern side. So that is why one will be 20 degree north and another will be 20 degree south latitude. I hope this is clear. Okay, so we will find more important things about these parallel lines. Okay, from like I hope you have understood about equator. Now axis, equator, these parallels of latitude little bit. So now let us try to understand little bit more important, some important parallels of latitudes are there. Okay, so we will learn about them. Okay, that is the tropic of Cancer, tropic of Capricorn, Arctic Circle and Antarctic Circle. There are 4 important parallels of latitudes. Okay, there are 4 important parallels of latitude. So let us try to understand it. So first, besides the equator, which is 0 degree, okay, the north pole 90 degree north, I hope it is clear now, and the south pole 90 degrees south. There are 4 important parallels of latitudes. So first is tropic of Cancer, which lies in 23.5 degree north in the northern hemisphere, that is here upward, isn't it, in the northern hemisphere, here it is here. Okay, tropic of Cancer, it is in the northern and 23.5 degree. Okay, next is tropic of Capricorn. Okay, next here, see, this is in this south, same degree here 23.5, here also 23.5, but what is the difference here? This lies in the northern hemisphere and this lies in the southern hemisphere. Okay, southern pole, south pole or north pole, same. Okay, so this the tropic of line that lies in the south pole is tropic of Cancer, and the tropic of the line, the latitudinal lines which lies in the northern of 23.5 is tropic of Cancer. I hope this is clear. And in the southern hemisphere. And next, third is Arctic Circle. Again same, these are again in the same degree, okay, 66.5, okay, 66.5 north of the equator. Here you will find this Arctic Circle, okay, here, and again Antarctic Circle over here in the south. Both of them are located in the same degree of latitudes. All right, so these are the 4 important parallels of latitudes. Okay, so let's try to learn one by one. Okay, what are these? There are some zones again divided. Why such lines they have given divide? Okay, why these latitudinal lines are given specific name? Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle. It is all because this all depends. This line divides the season of the earth. As we know that we don't have the same temperature all over the earth, isn't it? So this line are being divided for a reference. It will be easier for us to divide that, okay, in this portion from Tropic of Cancer to Tropic of Capricorn, over this it is the torrid zone, and upper it is the temperate zone, and this 66.5 degree north it is frigid zone. So let us learn about it more detailedly. Okay, that is why these names are being given. These names are being given to these 4 latitudinal lines. What are those? Tropic of Capricorn, Tropic of Cancer, Arctic Circle, and Antarctic Circle. All right, so let us see now next heat zone. Okay, we need this diagram as well in heat zone. Okay, let me read out and I'll explain you. Okay, the midday sun is exactly overheated at least once a year on all latitudes between the Tropic of Cancer and Tropic of Capricorn. This area therefore receives maximum heat and is called torrid zone. Okay, let us understand what is torrid zone. Okay, see this area, okay, this line you can see in all latitudes, which see there will be so many latitudes over here, isn't it? Again there are so many latitudes from starting from 0 over here, and again starting from 0 here, isn't it? So all these lines, we call these lines of latitudes in this area, from where Tropic of Cancer to Tropic of Capricorn, this area. In this area there is maximum amount of heat from the sunlight. Why? Because of revolution. Okay, Earth's revolution. Suppose this is the sun. Okay, see, as Earth will be revolving around it, isn't it? Earth will be revolving around it, and the sun is in the center. And what happens, as this is also in the center part, the rays from the sun, when this rays coming from the sun, this will be more harsh over this area, and that is why these are known as torrid zone. And these equatorial and that is why I hope you have also heard that it used to be very hot. It used to be very hot in the equatorial zone, in the torrid zone, especially in South Africa. South Africa is exactly in the equator line, isn't it? So this area, they receive heavy amount of sun rays, we can say, okay, heavy amount of sun rays, and all of these lines are overheated once a year. All these lines, one by one, all the latitudinal lines which comes under these Tropic of Capricorn to Tropic of Cancer to Tropic of Capricorn, all of them are heated, overheated, we can say, okay, overheated at least once a year. So that's why these may receive a maximum amount of heat, okay, and they are known as torrid zones. I hope this torrid zone is clear. So next let us see about the temperate zone. See here you can see north temperate zone and south temperate zone. Okay, we'll come back to the diagram again. Let us first read it out. The midday sun never shines overhead on any latitudes beyond the Tropic of Cancer and Tropic of Capricorn, beyond it, that is in the northern and the southern part. Okay, the angle of the sun's rays goes on decreasing towards the poles. As such, the areas bounded by Tropic of Cancer and Arctic Circle in the northern hemisphere and Tropic of Capricorn and Antarctic Circle in the southern hemisphere have moderate temperature. These are therefore called temperate zones. So why these are known as temperate, these are called as temperate zones? Because they receive lesser amount of sun rays as compared to this torrid zone. See, as this is in the middle, isn't it, and Earth is revolving, and sun rays goes straight in this torrid zone, so these will receive maximum amount of heat. So that is why they are known as torrid zones, they are hot zones. Okay, and this area, this northern and southern temperate zone, and when this sun rays, okay, the sun rays are not as very strong when it passes through this northern temperate zone and southern temperate zone. So that is why the sun rays are not as harsh and it is decreasing. Okay, it is decreasing when it's going towards this area, and it decreases more in this frigid zone. Okay, it decreases more. See the sun rays, it is decreases more. So that is why these are known as frigid zone, and these are known as temperate zone. There are decreasing sun rays as compared to torrid zone. And here in poles you can say that very little amount of sun rays will go. Okay, here in North Pole and South Pole, that is why they are been named as frigid zone, because you will receive like no amount of sun rays. Okay, very little sun rays. The sun rays are not as harsh or heated as compared to this torrid zone, as in torrid zone. So these were the heat zones. I hope it is clear. I have already explained about these frigid zone as well. Okay, so you can read it out. See, well, let's read out together once more. I have explained. Okay, areas lying between the Arctic Circle and the North Pole in the northern hemisphere and Antarctic Circle in the southern hemisphere are very cool. It is because here sun does not rise much above the horizon. Therefore, its rays are always slanting and provide less heat. Therefore, these are called frigid zones. So, and very cold. I hope this is clear. Okay, in the middle part it is very hot, so that is known as a torrid zone, and in the upper here the temperate zone over here in this area. Okay, from these Arctic Circle to these north temperate zone and south temperate zone to this Antarctic Circle, the sun rays are decreased. Okay, so that is why these are temperate zone, and here you will find the weather is not as harsh in as compared in this equator. Okay, and above that from Arctic Circle to North Pole and Antarctic Circle to South Pole, you will find the sun rays are very less or very in less amount and less heat. So this area is known as frigid zone. So these were the heat zones. Okay, heat zones of our Earth. I hope you have understood these heat zones. Okay, so that was about the latitude. Okay, so next topic we have is the longitudes. I hope about latitude it is all clear. So in latitudes, what are the major things that you have to remember? That North Pole, South Pole. So North Pole, South Pole, it is over there. Okay, in the Earth. And in latitudes, what you need to remember? The important parallels. Those were the Tropic of Cancer, Tropic of Capricorn, Arctic Circle and Antarctic Circle, and along with that the heat zones, because latitudes, through latitudinal lines we came to know the season, as we have divided the torrid zone, temperate zone and the frigid zone, isn't it? So that was all about latitude. So now let us see longitudes. So longitudes are connected with locations and time. Okay, directly connected with locations and our time. And again, one more time, let me remind you, these are all imaginary lines. Okay, in practical, in real Earth, no such lines are drawn. Okay, no such lines, you will not find any such lines. These are all imaginary line. Okay, so let us start longitudes. Okay, see again, longitudes means the long line. See here, long, isn't it? Latitudes mean the landing line, lating, isn't it? And these longitudes are this long line that, as you can see here in this picture. Okay, these are all longitudinal lines, long, standing long and erect, isn't it? Okay, to fix the position of a place, it is necessary to know something more. Okay, to position of a place, it is not only latitude alone is not enough. Okay, because what happens if, like here the example is also given, if same islands, okay, same two places are situated in the same degree, front side and back side, it will be difficult. But if there is a longitudinal point, then it will be easier for us to locate that very point more precisely. Okay, so you can see, for example, that Tonga Island in the Pacific Ocean and Mauritius Island in the Indian Oceans are situated on the same latitude, that is 20 degrees south. See, 20 degrees south and downside, front side, and see this line, the latitude lines, for example, this is the latitude line and this is the 20 degree. Okay, so this front side and back side. So one is located in the front side of 20 degree and another is located in the back side of 20 degree. So what happens? And that is also both in the southern hemisphere. Then so in order to do more precisely, so this is again we have another division, another imaginary line, that is known as longitudes. Okay, so we'll be seeing whether it is south degree, east or west. That will be for longitude. All right. So So now in order to locate them more precisely, we must find out how far east or west these places are from a given line of references running from North Pole to South Pole. So this line of references are called meridians of longitude. So this line, so this here again, this is also again divided by one meridian, prime meridian or the Greenwich. Okay, so again this is just like the equator. The equator was divided like this half, isn't it? So just like this, another line is divided here, that is known as the meridians of longitudes. Okay, meridians of longitudes, and this line which lies on the eastern part is known as the eastern longitude, and again the lines which are on the western parts here, these are the western longitude. So this help us that that very place, whether it is in the western side or in the eastern side, how west, how much west, or how much, how east or how much west. Okay, how far, sorry, how far east or west these places are. Okay, are called the meridians of longitudes, and the distance between, okay, and the distance between them are measured in degrees of longitudes. Again, this distance between, in latitudes also we have measured the distance in degree. Again, this distance here, these are also again measured in what, in degree. Okay, degrees of longitudes. Okay, let us see here. Each degree is divided into minutes. See, this degree is minutes. Why minute? Because this is the line, imaginary line through which we came to know about, which we have divided about the time zones. Okay, about our time. So these are divided into minutes, minutes into seconds. They are semicircle, and the distance between them decreases steadily polewards until it becomes 0 at the pole. See, unlike the latitudinal line, those are not decreasing, isn't it? Those are not decreasing, but here see, those are not of equal length, you can say. Latitudes are not of equal length, but they are not decreasing, isn't it? They are not decreasing, and they are going on like this. But these latitudes, when they are going towards the pole, they are decreasing. Okay, their length, their space, okay, their length is decreasing, but not the line. Okay, but not the line. So here, see, when you see, you have drawn this line, this imaginary line, this is the prime meridian, isn't it, the center part here. So this is the prime meridian, and here you will see this longitudinal line. So when it goes into pole, it becomes smaller, it becomes decreased, isn't it? When they meet, when they are meeting in the northern pole as well as in the southern pole, what happens? These lines are becoming smaller, isn't it? These lines are becoming smaller. So okay, yes, and where were we? Okay, yes, this is what I have told you. Okay, this meet, and unlike parallels of latitudes, all meridians are of equal length. Okay, so these latitudes, they were not of equal length, isn't it? Here the length will be shorter, here the length area on that equator will be longer, but in case of longitude, all these lines are of equal length. Okay, only the space here towards the pole decreases. All right. So thus it was difficult to number the meridians, hence all country decided the count should begin from the meridian which passed through the Greenwich, where the British Royal Observatory is located, and this meridian is called the prime meridian. Okay, so see, as this is decreasing when it's meeting the pole, isn't it? So it becomes difficult to number the meridians. Okay, it becomes difficult to number the meridians. So what they have decided, so they have drawn a line just like the equator. Here in the middle, that is the prime meridian, and from here they are going to decide the prime zone. Okay, this side will be ahead, eastern side will be ahead, and western side will be behind. Okay, in that way they have decided, and that line, this line crosses which area, which place, that is the British Royal Observatory located. Okay, Greenwich, and this is known as also the Greenwich. Okay. Okay, its value is 0 longitudinal, and from it we count 180 eastward as well as 180 westward. The same concept again. Okay, here this line will be again 0, and from it will be again 1, 2, 3, just like this in the easternward 180 degree, and again here in the westernward 180. So 180, 180, what it will make? 180, 180, it will make again 360 complete circle, isn't it? So the prime meridian and 180 meridian divide the earth into two equal halves. So again, see, this also again divides the earth into two equal halves. This is the western part, western side, and in the eastern side, one in the western side and another in the eastern side. That is the eastern hemisphere and the western hemisphere. See, just like here what we have named, the northern hemisphere, this is southern hemisphere. Now this becomes the western hemisphere and this become the eastern hemisphere. Okay, therefore longitude of a place is followed by letter E for east. So for letter E for the east direction and letter W for the west direction. It is however interesting to note that, okay, one interesting fact is here, 180 degree east and 180 degree west meridians are on the same line. See, 180 degree east and 180 degree west is both of them are in the same line. Okay, because it is decreasing, isn't it? When it comes to the pole, it is decreasing. So both of them are in the same line. Okay. All right. I hope until here it is clear. So now let us try to observe it in more detail. Okay, how we are going to locate the place. For that you need to look into these grids given over here. Okay, here this one. Now look at the grids of the parallels of latitudes and meridians of longitudes. Okay, grids of latitudes, parallels of latitudes as well as longitudes. So imagine these as the longitudes and these as the latitudes. Okay, so you can locate any point on the globe very easily if you know its latitude and longitudes. So if you know that in which latitude degree, for latitude also there is degree, isn't it, starting from equator 0, and here in prime longitude also it is also again measured in degree starting from prime meridian as 0. So it is easier for us if we know and place exactly where it is located through this line. All right. So for example here, Dhubri in Assam is situated at 20 degree north latitude, let us say, okay, 20 degree north latitude and 90 degree east longitude. So it is in the 20 degree north latitude. So suppose this is the equator, here it will be the 20 degree, and here again eastern, this is the again eastern part, isn't it? So somewhere here it will be located. Okay. So find out the point where these two lines cut each other. That point will be the location of Dhubri. Suppose this is the 20 degree. Okay, this line which I am drawing here is the 20 degree, and this line, it is the 90 degree east, as eastern side is over here, isn't it? This is 90 degree east. Then this point, this 20 degree, at this 20 degree point, that line where it intersect, this point will be the Dhubri in Assam. So in that way we are locating that place. So like that they are giving another degrees and place. So just like that we have located these places. Okay, you can locate it more. To understand this clearly, draw equidistant vertical and horizontal line on a paper. So just like here. Okay, and label vertical those, okay, which we have already done, and vertical lines intersect each other. Name this small circle as A, B, C, D and E. Let vertical lines represent east longitudes and horizontal line represents north longitude, latitude. So this will be represent north latitude and this will represent east longitude. So you can see a circle A is located on B degree north latitude and 1 degree longitude. So here B degree 1, isn't it? B degree 1 latitude and A degree north latitude. So in that way we are locating places. Okay, I hope this was clear. Okay, so that was about how we locate a place. Next let us see about the time, zone. Okay, say Greenwich here. As I have told you, see, this is the prime meridian. Okay, this line is the prime meridian and this side is this is the eastern hemisphere, isn't it? Eastern hemisphere of longitudinal lines, and this side it is the western hemisphere. So this time zone, okay, this time zone, try to understand this. Okay, this time zone, this eastern side is ahead of Greenwich and this side is behind of Greenwich. Suppose if it is 12 o'clock in Greenwich, then in 15 degree, because 15 degree is equal to one line, okay, one longitudinal line. So here it takes 1 hour. Okay, so then if it is 12 in the Greenwich, then in the eastern part, in the eastern side it will be 1 p.m. 1 p.m. noon, and here in the western side it will be 11 a.m. Okay, so such a difference, like it is like that. So let us try to understand that as well. Okay, So longitude and time. This is also a very important and very interesting chapter as well. So let us try to understand this. Okay, longitudes and time. The best means of measuring time is by movement of the earth, the moon and the planets. The sun regularly rises and sets every day, and naturally it is the best timekeeper throughout the world. Local time can be denoted by the shadow cast by the sun, which is the shortest at the noon and longest at the sunrise. So in the ancient time, when these such lines were not imagined and not made, let us say, okay, like when there was no educations or nothing, during the early age time or during the stone age time, how they used to measure the time by looking at the sun. Okay, they will be saying that if your shadow is short, then that will be noon time, and if your shadow becomes longer, then that is the time of sunrise. So in that way they used to measure the time. But now, as we have this imaginary line and we have created this time zone as well, so it is very easier and convenience, isn't it? Like you will be asking what time is it now, then easily you will be saying, okay, it's 1:30 p.m., isn't it? So it is all possible only because of those longitudinal lines. And the standard time of the world, it is divided, it is taken as the Greenwich time. Okay, Greenwich time is the standard time of this world. Okay, let us try to understand more. When the prime meridian of Greenwich has the sun at the highest point in the sky, when in that prime meridian, let's suppose this is the world map. Okay, just suppose, and this is the world map, and this is the Greenwich. Okay, Greenwich prime meridian. Suppose it is this area, okay, has the highest sun in the sky, then it will be 12 noon, isn't it? It will be 12 noon in this area, in this Greenwich, and all the places along this meridian will have midday noon. And as earth rotates from west to east, see, from west to east, isn't it? From west to east. So because of that concept, this is behind and this is ahead. Okay, so those places east of Greenwich will be ahead of Greenwich time, and those to the west will be behind it. All right, and the rate of difference can be calculated as follow. See, as the earth moves from western to eastern side, it is rotating, isn't it? It is rotating in itself as well as revolving around the sun. I hope you know the concept of rotation and revolution, isn't it? Rotating means it is rotating on its own axis. One complete rotation will mark one day, that is 24 hours, isn't it? One day equal to 24 hours, one complete rotation, and one complete revolution, it is 365 days, isn't it? Which marks 1 year. I hope you know this concept. So with that concept, what happens when earth is rotating from west to east? Yes, it is rotating from west to east, so this will be behind. Okay, this side, this western side, it will be behind, then in eastern side will be ahead of this Greenwich time. Okay, that is why suppose it is daytime in India, then it used to be nighttime in America. It is all because of this time zone. Okay, and this lies as both this country lies in a very different parts of the world, isn't it? And it is very far away as well, and the timing of sunrise and sunset is not same, isn't it? Because when sun rises in the India, because when sun is facing in the Indian side, because the earth is rotating, and when the Indian side is going to the sun, around the sun, facing the sun, it becomes daytime, and night, backside of that area will be night, isn't it? So in that way this time is divided. Okay, now let us see more here, or let us see how this calculation will be done. Okay, let us try to learn this calculation. The earth, see, try to understand this concept. Okay, the earth rotates 360 degree. Okay, understand this concept. Okay, the earth rotates 360 degree in about 24 hours. See, in a day we have 24 hours. So in 24 hours, how much it rotates? It rotates 360 degree of longitudes. Okay, so which means 15 degree an hour. So when we divide 360 into by 24, what we'll get? We will get 15, isn't it? So 15 degree in 1 hour, isn't it? 15 degree in 1 hour. 15 degree in 1 hour and 1 degree in 4 minutes. Again, if we divide this 15 in 15 degree, then what we will get? We will this 15 degree we will get again 4 minutes, isn't it? 4 minutes. When when we divide, see how we are going to divide in 1 hour, how much time is it, how many minutes is it, it is 60 minutes. So 15 divided by 60, how much will come? 4, isn't it? So in that way 4 minutes, okay, 4 minutes. So that means 1 degree is equal to 4 minutes, isn't it? I hope this is clear. Thus, when it is 12 noon at Greenwich, the time at 15 degree east of Greenwich will be 15 into 4. Okay, that is 60 minutes ahead of Greenwich. So, in that way, this is ahead and this is behind. Okay, I hope it is clear. So, see, as 1 degree is equal to 4 minutes and in 1 hour 15 degrees been covered. So, when it is 12 noon in Greenwich, then in east it will be 1 p.m. isn't it? 1 p.m. and in western it will be in western side it will be what? 11 a.m. Understood? Okay. So 1 hour ahead of Greenwich time, which means 1 p.m. but 15 degree west of Greenwich. The time will be behind Greenwich time by 1 hour. That will be, it will be 11 a.m. Similarly, at 180 degree it will be midnight. See, again in the 180 degree it will be midnight. If when it is noon here, but in 180 degree what will happen? It will be midnight if you calculate. Okay, and when it is 12 when it is 12 noon at Greenwich, see here, this is the front part. Okay, this the front part, if it is 12 noon, and the back side it will be midnight. That is within the 180 degree it will be again night. Okay, so here see 180, see if it is 12 noon here in this Greenwich, and when this 180, say 180 will be here, isn't it? The last line, this last line will be 180 longitude, 180 degree longitude. So here what will happen when it is 12 noon here it will be night. Okay. Okay, so I hope you have understood this calculation. At any place, a watch can be adjusted to read 12 o'clock when the sun is at the highest point in the sky. When it is midday, the time shown by such a watch will give the local time for that place. See, when we are going into any area and you observe that it is the sun is at the highest place, it is in the middle, and your shadow looks very shorter, then based on that also you can adjust your clock and you will be on that local time of that very area. Okay, you can see all the places on a given meridian of longitude have the same local time. So in a longitude given meridian of longitude, you will notice that all the places will have the same time. Okay, next we will understand why do we have this standard time zone. Okay, why do we adopt this standard time zone? As we have seen that if it is 12 noon in the Greenwich, in 180 degree it will be night, and which country will be located in that 180 degree? Because of that there is a time difference, isn't it? So there is a need to adopt some standard time, so that Greenwich is the standard time for the world. Okay, so now here for India we will try to understand, okay, in which point, which degree we have considered it as a standard time, we have taken as standard time. Okay, the local time of a place which are on different meridians are bound to differ. Okay, in India itself also there is a difference on from west and east, isn't it? Like in eastern part the sun rises early, it is ahead, isn't it? It is ahead of time, and in the western part it is late. So that is, there is almost 1 hour and 45 minutes of difference. Okay, but as we have adopted a standard time, all like if it is 6 a.m. in the eastern side, it will be 6 a.m. in the western side also. But the light in the eastern, you will find that sun rises at 5 a.m. and in the western side sun will rises at 7 a.m. okay, around 7 a.m. So that is why, okay, this is the reason behind this difference of time. I hope it is clear. So now let us see this standard time concept. I have already explained also. The local time of a place which are often different on different meridians are bound to differ. For example, it will be difficult to prepare a timetable for trains which cross several longitudes. Say if we adopt different time zones for different area, for different longitudes here in India also here different longitudes, then it will be difficult, isn't it? Suppose the train is for 1 p.m. according to my country, according to my state, then what will happen? But according to another state the train is of 2 p.m. then there will be confusion, isn't it? Confusion created. That is why in order to remove such confusion, such a standard time is been created. Okay. For example, in India, there will be a difference of about 1 hour and 45 minutes in the local times in Dwarka in Gujarat, okay, here and over here, okay, and Dibrugarh in Assam. So from here to here, see, longitude, the high, the space is high, isn't it? The distance is high. So the time zone will be different. According to longitudes, we should adopt a different time zone. But what happens, as we are a country, what we have done, we have taken a standard meridian, just like the Greenwich for the world. For our country also we have taken a standard time, because our country is not that very big country like Russia, but in Russia you will find 12 time zone, because it is not possible for them to adopt the standard time, okay, as it is a very big country. Okay, so it is therefore necessary to adopt a local time of some central meridian of a country as the standard time for the country. So straight in the half, again these our country has been again divided based off time, okay, based on for time, standard time. See here, from here to here you will see this difference, and sun rises here early, so this time should be ahead, isn't it? 1 hour and 45 minutes, see, 1 hour and 45 minutes ahead. Suppose if the sun rises here at 5 a.m, then here the sun will rise at what time? 6:45, isn't it? So, okay, in India the longitude of 82.5 east, okay, here 82.5 east is the eastern side, okay, India lies in the eastern hemisphere, so eastern side is treated as the standard meridian. The local time at this meridian is taken as the standard time for the whole country. So this time, this area, okay, this line you can see, okay, this line is been treated as what? As standard time for whole of the country, okay. The local time, okay, it is known as the Indian Standard Time, IST, okay, Indian Standard Time. So this area here into 80 to 82.5 minute eastern hemisphere, what we have done, eastern longitudinal hemisphere, what we have done, we have taken it as a standard time, and it is the time of whole of our country, okay. I hope you have understood. Next, okay, one more example is given here, okay, of time. It will be more clear with all of you. Kabir lives in a small town near Bhopal, okay. He tells his friend Alok that they will not be able to sleep tonight. A day and night cricket match between India and England had started at 2 p.m. in London. This means that the match would be at 7:30 p.m. in India and finish well in the midnight. Do you know what is the time difference between India and England? See, when there used to be cricket match or football match, any match, when it is been played in the foreign countries, then because of these different time zones, I hope it is more clear to you now, because of these different time zones, as they are located into different degree, longitudinal degree, isn't it? There will be more difference, isn't it, based on that Greenwich, whether they are in the eastern side or in the western side. So here in England, what happens, as India is in the eastern side and this England is in the western side, okay, western hemisphere, so western longitudinal hemisphere. So what happens, India is ahead of them, okay. So when it is 12 p.m. noon, okay, when it is 12 p.m. in London, what happens, it will be 7:30 p.m. in India. That means how much ahead we are? We are 5 hours and 30 minutes ahead of England, okay. So India is located in the east of Greenwich, 82 degree 30 minutes east ahead of GMT, that is this Greenwich Meridian time, okay. So it will be 7:30 in India when it is 2 p.m. noon in London. So I hope you have understood this concept. Some countries have a great longitudinal extent. So this is about Russia, okay. Some countries have a great longitudinal extent, as their country are expanded in a great area, okay, great area, and so they have adopted more than one standard time. For example, in Russia there are many as 11 hours each, okay, 11 standard times. So 11 standard times. The earth has been divided into 24 time zones of 1 hour each. Each zone does cover 15 degree of longitude. I hope you have understood this also, as Russia is very big, but what they have done, they have adopted 11 standard time. See, in India it is we have adopted only 1 standard time, isn't it? But in Russia they have adopted 11 standard time because of their huge area of their country. It is not possible for them, because if they have adopted only 1 standard time, just like our country India, what will happen? Like suppose they have adopted say 5 a.m. according to a place, but on that very time in the other place, as it is a very huge country, not some other longitudinal extent, what will happen? There will be night. So it is not possible for them to go for a 1 standard time. So that is why they have adopted 11 standard time. So with this we have completed this chapter. I hope this chapter latitudes and longitudes is crystal clear to all of you. Okay, if you have any doubts or any such queries, you feel free to comment down. Okay, I'll try to try to clarify all your comments. And thank you for watching my video, and do subscribe, like and share with your friends and family as well, and all the students, those who know, okay, those who really need this, and especially for those candidates also who are preparing for competitive exams. This will be very helpful, as this chapter is very important. Okay, if you don't know anything about geography, when you are, if you are trying to start something about geography, you have forgotten everything, this chapter is the best. Okay, so you, from here you will learn the basic feature, isn't it? This is just like a basic feature about our earth, like we have known about how the season, why there is a difference of season, and why time zones, isn't it, based on latitudes and longitudes. So I hope you have learned well through this. So keep watching and keep supporting. Thank you everyone. See you in my next video.